Welcome to this Leapfrog Geothermal best practice video. The theme of this video is editing intrusion surfaces built from well data. My name is Bastien Poux. I am the Technical Sales Advisor for Energy at Sequent. It is my pleasure to present you this video. Please note the objective of this video is to focus on the tools in Leapfrog Geothermal and to give you helpful workflow ideas and tips and tricks to elevate your modeling skills. The material covered in this video is meant to be high level and is using a simplified dataset. It is best to derive contact surfaces from well data when it is available. The well data are imported in Leapfrog from the well data folder, from CSV tables, or from a compatible well database such as iPoint. Intrusion contact surfaces are rounder in shape, with an entire lithology that represents the intrusive lithology. The intrusion removes existing lithologies and replaces them with the intrusive lithology on the younger side of the contact surface. Often, the other side of an intrusion contact is labeled as unknown in Leapfrog, as typically, intrusions displace multiple older lithologies. To build surfaces, Leapfrog Geothermal uses the fast radial basis function, or fast RBF algorithm, which employs interpolation functions to estimate values from known data. This process is fast and dynamic. One of Leapfrog's core strengths is building initial surfaces directly from well data, without the need for extensive manual digitization. However, in most cases, those initial surfaces won't match exactly your interpretation. Leapfrog has several tools that allow you to quickly manipulate and edit these first-pass surfaces to honor your data and your interpretations. Depending on the extent of editing a surface requires, you may need to employ any or all of these editing tools. For surfaces that may require manipulation from several editing tools, editing is most efficient if applied in a strategic order. In this video, we will recommend an editing order of operations. Depending on the issue you're having with your surface, the edits can be applied in a slightly different order, or certain editing options can be skipped altogether. We are now in Leapfrog Geothermal, where we have created a new project. As a reminder, you find on the left the project tree. In the middle is the 3D scene. Below the 3D scene, you will find the shape list, and at the bottom right is the property panel. Above the 3D scene, you will find the toolbar. We're going to start this project by importing a topography. For this, I right-click on my Topographies folder and select Import Elevation Grid. I can look for my DM model in my folders and open it. The default resolution is 10 meters. It is clipped to the boundary, so I can import it. It is now going to appear below my Topographies folder, and I can drag it in. Next, I am going to import a map, and there is a satellite image available, which I'm going to open. This one is already GeoReference and appears directly under my GIS data maps and photo folders. In the shape list, in the drop-down menu below the topography, I can select directly my image in Maps and Photos to visualize this satellite image on the topography. The next thing we're going to do is import the well data. For that, I can right-click on the well data folder in the project tree, select Import Wells, and look for the CSV tables with my information. The first one is the location. I can browse in my folders and look for the location table and open it. Automatically, Leapfrog found the other table called Survey and Lithology. I can now click Import. Next, I need to check that the columns are being imported correctly, well number, X, Y, Z, and the total depth. I can click Next. For the surveys, I have the well ID, the depth, the dip, and the azimuth value. In the next table, I will find my lithology. It also has the well ID, the from and to intervals, and the lithology type. I can now click on Finish. After being processed, the well data will be available in the project tree on the left. You can drag in the lithology to see the well traces with the lithology types. You can click on the pink button in the shape list to visualize the wells as tubes. You can change the diameter. Here we're going to make them a little bit smaller. And then you can also decide to change the colors by clicking on Edit Colors and click on the color box to choose a new one. We're going to choose a tough orange, a green for the basement, and we're going to put our dacite in red. You then have to click on OK to keep those colors. You can turn around the scene to look at the well data. We can also add the legend to know what the colors correspond to. And if we want to remove some of the lithologies, click on Edit Colors and deactivate the basement and the andesitic tuff. We now see only the dacite, which is the one we're going to use to model an intrusion. It is present in most of the wells, but not in all of them. Next, we're going to create our geological model. Right-click on the Geological Models folder and select New Geological Model. In the new window that opens, Lithology is already selected. We're going to lower the resolution to 100, and we're going to make sure that the boundary of the model is based on the well data. Here we can see that it's a bit below the topography, so we're going to increase the maximum elevation, and we're going to extend using the red arrows to the boundaries of our satellite image. And then, after renaming it Geological Model, you can click OK. Once the model is processed, it will appear in the project tree. The geological model is made of a boundary, a fault system, the lithologies, which are defined by the well data. Everything is now ready to start building the surfaces. We start by the youngest lithology, which is going to be the intrusion. We're going to right-click on Surface Chronology, select New Intrusion from a base lithology. In the window that opens, we're going to select for the entire lithology our dacite, which is the intrusive body. The andesitic tuff and the basement are outside of the dacite. They are older. This lithology is called dacite. You can click OK. Once it's done processing, you can drag in the surface dacite into your 3D scene. You can rotate around the scene to look at the surface that was generated. The next thing to do, if we put back the well data, by clicking on Edit Color, you can reactivate the andesitic tuff and the basement. There is another surface to build, the contact between the andesitic tuff and the basement. We're going to create a new surface as a new deposit from a base lithology. For the primary lithology, we select the andesitic tuff. We're going to use the contact below, which are those with the basement. The dacite must be ignored, as it is a younger lithology, so we're going to drag it to the right into the Ignore Lithologies category. We can now click OK to create the surface. Once processed, it will also appear in the project tree and you can drag it in. From the surfaces, we can see that the dacite intruded through the basement and the andesitic tuff. We are now going to see what editing tools are available in Leapfrog Geothermal, how they work, and what is their purpose. The tools can be divided in two categories. The surface editing tools, which are accessed by double-clicking on the intrusion surface in the project tree, and the input data editing tools, which can be found below the intrusion surface in the project tree too. Note that some of these tools are more advanced and require some knowledge on how the RBEF interpolant works. There are 5 different tools that can be used to edit the surface: the resolution, the snapping, applying a trend, value clipping, and changing the interpolant type and its parameters. When editing the input data, there are 4 different tools: upscaling, controlling the point generation, adding additional data, and using the manual refining tools. We are now going to go back to the model in Leapfrog Geothermal to try these tools and see how they work and what they do. We are now back into Leapfrog Geothermal. We're going to start by removing all the other layers than the intrusion, so the topography, the basement and the andesitic tuff, and for the lithologies, we are going to keep only the dacite. We will also give some transparency to the intrusion surface so that we can see the data from the wells. We can already notice that some intervals have not been included inside the surface and that some parts of the surface are not connected. Let's start with the resolution. You can change the resolution of the whole geological model by clicking on the geological model in the project tree. But you can also change the resolution of a single surface. Double-click on the surface in the project tree and go in the Surfacing tab. Currently, the resolution is inherited from the GM. For intrusion, that resolution is half the resolution of the GM. If you uncheck the box, you can enter manually any value you wish for the resolution. Here we're going to select 25 and click OK. The model will reprocess. We can see that the surface is now a lot smoother. Changing the resolution for a particular surface is useful if you want to build a detailed model of some lithologies without increasing the processing times for the other volumes. When we zoom in the middle of the intrusion, we can see that the surface is passing through this well, not exactly at the point of contact. To exactly honor the contact point, we will be using the snapping tool. The snapping can be set for the entire model at once or can be done on a surface-by-surface basis. You can set the snapping for the whole geological model by double-clicking on the geological model and changing the parameters of the snap to data. Here we will change it directly on the dacite surface. Go into the Surfacing tab, and the second option is the snap to data. Here we're going to set it to drilling only. You can select the distance. The maximum distance to snap equals the resolution of your surface. The surface is going to reprocess, and now we can see that it honors exactly the contact points of the wells, which you can see better if you turn off the well data. For the rest of this exercise, we will put the snapping back to the default settings from the GM. The surface is being reprocessed, and we're now going to look at the next surface editing tool, applying a trend. Our intrusion surface currently is quite round in shape. Applying a trend will permit to stretch this surface in any direction. You can turn off the surface to see better the well intervals. Often, the easiest way to apply a trend is to click on the Draw Plane Line button in the toolbar and to draw a plane line in the scene in the direction in which you wish to adjust the surface. You may need to rotate the scene to see the plane properly. We can now use this plane and assign it as a trend in our surface. For that, I go into my dacite surface, and the last tab is called Trend. By clicking on the button Set from Plane, I will copy the coordinates of the plane I just drew in the scene, and I can assign different ellipsoid ratios. I'm going to keep the default one and click OK. The surface is going to reprocess, and now we can see that it has been stretched along the plane direction. If I feel that my surface has been stretched too much, I can go back into the trend and set the ellipsoid ratios to lower values, for example 2 and 2. The surface will be reprocessed with the new ellipsoid ratio values. If I'm happy to keep this surface, I can remove the plane. If I wanted to remove my trend, I will have to click back on my dacite surface, go back into the Trend tab, and set to, I can assign it to isotropic. And this will cancel the trend I applied. Here I will just cancel to keep my previous trend. The two last surface editing tools that I will demonstrate now are the value clipping and the interpolant function. They are more advanced and require to understand how the RBF function works. To access them, you also need to click on the dacite surface in the project tree. Under the Surfacing tab, there is an option at the bottom called Additional Options. When you click on it, two new tabs will open at the top, Value Clipping and Interpolant. We're going to start now with the Value Clipping. In the Value Clipping tab, you can manipulate the data distribution. Clipping caps values that are outside the range set by the lower bound and the upper bound values. To understand what those values are when we're talking about lithologies, you have to understand how the RBF works. In the project tree, if you click on the black triangle under the dacite, you can drag in the input points that were used to build the surface. If you click on the A, you can see the values that were assigned along the well. The numbers that you see here represent the distance from the surface. Red values are positive, they are inside the lithology. Blue values are negative and they are outside the lithology. If we go back to the histogram in the Value Clipping tab and deactivate the automatic clipping and the clipping, we can see the histogram update to show the distribution of all the values. In that case, all the values of every point will be used to build the surface. If I do clipping, all the values that are below the lower bound will be assigned to the lower bound value. All the values that are higher than the upper bound will be assigned the upper bound value. Here minus 54 and plus 54. These two values were calculated automatically by the software based on the data. I am now going to reactivate my dacite surface so that we can see the changes. First, I'm going to change the lower bound to a lower value, minus 200. This will increase the influence of the points that are outside the surface, the negative values. The histogram below will automatically update to fit minus 200 as the lower bound. I can now click on OK to see the changes in my volume. By increasing the influence of the lower values, I have reduced the volume of my dacite intrusion. Now let's try the opposite. I go back into the value clipping tab, and I will set the lower bound back to -54, but this time I will change the upper bound up to 200. The histogram as well will update with the new values, and you will see that the upper bound is now at 200. I can now click OK to reprocess the surface. And the result shows that by increasing the upper bound value, I have increased the influence of the positive values on the surface generation, and the volume of the dacite has increased. For the rest of this exercise, I will set back the value clipping to automatic clipping and click OK to reprocess the surface. We are now back with our original intrusion. I can remove the value points, and we're going to look at the last advanced editing surface tool, which is to modify the interpolant. When you click on the Interpolant tab, you're going to see the parameters that were defined by default. Currently, the relation between the interpolant and the distance is linear. For the linear interpolant, the cylinder range don't have any importance. The other type of interpolant available is the spheroidal interpolant. The distribution of the interpolant with the distance is not following a linear trend. The range is an important value. It is the distance where the interpolant equals 90% of the seal. For more information on the settings in this tab, I invite you to watch the best practice video on how to build a temperature model from well data. In that video, the different interpolant functions and their parameters are explained in more details. By lowering the base range to 300, we pretty much decrease the radius of search to build the surface. As a result, we end up with several disconnected bodies to constitute the intrusion. The opposite, if we want to increase the range, we go back into the Interpolant tab. To make sure we cover the maximum distance between the data, we can directly measure in the scene using the ruler. We see here that the wells that are the further away are about 2.2 kilometers distance. We can assign, as the base range, a value that is higher than this. For example, 3000 meters. And then we click OK. The model will be processed and connect the points by looking at the data further away. We now have an intrusive body that connects all the dacite intervals in the wells. Now if we go back into the Interpolant tab, and we assign to the range value the highest value possible, here 10 kilometers, we see that in the distance separating the wells of about 2.5 kilometers, the relation is linear. In that case, the intrusive body that will be generated is very close to the one of the linear interpolant. As you can see now, if we go back to the interpolant and set it back to a linear interpolant, the resulting surface for the intrusion is the same. We have now looked at the 5 surface editing tools: the resolution, the snapping, the trend, the value clipping, and the interpolant parameters. We will now start looking at the input data editing tools. Whether it is to modify the way the well data are used to build a surface, to add additional data types, or to do some manual refining. We are now back into Leapfrog Geothermal. We are going to start by reactivating the different lithologies in the wells. Click on Edit Colors and reactivate the other lithologies. Below the dacite surface in the project tree, you find the dacite points that we have used earlier. Double-click on it to open the editing tool. A new window opens. The first tab is called Lithology. Here, you can modify the chronology between the different lithologies of your project. In the second tab, you have the upscaling tools. First, you can choose to convert the enclosed ignore segments into dacite. Means that any well that has an interval with no lithology will become dacite. The second box lets you choose the settings for filtering the short segments in the lithology. In the scene, you can see, for example, that those 2 intervals have not been considered the same way. The first one, which is about 10 meters thick, has not been integrated, whereas the second one, which is 15 meters, has been integrated inside the surface. By default, the filtering is applied based on the resolution of the surface. The surface here is 25 meters resolution, so the filtering applies to segment less than 12.5 meters. Interior segments are those of the dacite lithology. Exterior segments are the other lithologies around those intervals. The current filtering applying to segments less than 12.5 meters, I can change this value to a value lower than the 10 meters of this interval. I can click OK, and the surface will reprocess to integrate those intervals. In the opposite case, where we have an exterior lithology segment that is being kept outside of the surface, we can also filter this. This interval, for example, is 13 meters long, where the filters currently applies to 12.5 meters. If I put a higher value, such as 15, this interval will not be considered anymore. The surface now is a lot smoother. If we look around the intrusion, we can look for other intervals. For example here, there is a small interval not included inside the lithology. This one is actually 8 meters long, but is not included in the surface. The reason for this is the 33 meters interval of andesitic tuff below it, which is larger than the 15 meters filtering we applied for exterior lithologies. So if I go back into my upscaling parameters, and instead of 15, I put a higher value, like 50, which is more than the 33 meters, then this interval would be included inside the lithology. The second input data editing tool is the point generation, which is located in the third tab. To understand this tool, we need to reactivate the volume points, showing the numeric values assigned to the different intervals. We are also going to remove the lithology, and instead we're going to drag in the well traces from the project tree under the wells. The surface offset distance parameter sets the top and bottom ends of the interval and affects how a surface behaves when it approaches a contact point. A smaller distance restricts the angle that an approaching surface can take. We are going to lower this number to 10, and you can see that the interval for the surface to pass is much smaller. The background field spacing parameter determines the approximate length of segments in the remaining intervals. A smaller value for the background field spacing means a higher resolution and therefore slightly smoother surfaces. However, computation may take longer. We are going to lower this number from 100 down to 20. The number of volume points is much higher, as you can see along the well path, and the surface generated is a lot smoother. We are going to put the value back to the 100 to lower the computation time. We are now back with the similar surface as we had before. We can also remove the volume points that won't be necessary for the rest of this exercise. Besides editing the input data, you can also add new data. To do so, you can right-click on the dataset and go into Add, and here you can select to add points, contacts from other well data. You can add GIS lines or vectors. You can add structural data or polylines. These files need to be already existing in your Leapfrog project. You can also manually add new polylines or structural data. We're going to do an example here first with the polylines. We're going to select an area where there are not too many well data, because that is typically the areas you want to edit manually. So we have one here in the front. We're going to look from above on our intrusion. The easiest way for that is to press D on your keyboard. And we're going to do a slice for the area where you want to edit. So you use the slicer tool. You can slice the model to show exactly the area where you want to draw your line. And then you're going to press L on the keyboard to be perfectly perpendicular to the section. In the toolbar above the scene, you can select the drawing tool, and you are going to select Draw 2D lines on the slicer. And now you can start to manually draw a polyline on the section. You can use the Bezier point to control the curvature and draw the line where you want the surface to go. Make sure the right side of the ribbon indicates the inside of the lithology. If not, you can always click on the button in the toolbar to revert the polarity. And when you are done editing, simply click the Save button and the surface will update. We can see that the surface is going through the polyline that we just drew. This shows you how to edit the surface using the polylines. We can do the same thing and edit using structural data. In that case, the toolbar will show the structural editing tools. and you can select the tool to draw a new disk, put it on the slicer, and you can put it a bit away from the surface. I'm going to make it a bit bigger so that we can see the disk. You can move this disk to where you want the surface to go. You can change its orientation. And using the green arrow, you can also displace it. You can put as many disks as you want. Here we can just do with one. We're going to save. And now you can see that the surface is reaching out to the disk. We have now reviewed all the different editing tools for the intrusions. What we have left to do in this model is to build the volumes. For that, we have to first set the chronology between the different lithologies. So we double click on the surface chronology. We're going to start by activating both surfaces. And here the dacite has to be moved as the youngest lithology. You can now click OK. And this will process to create the volumes. The volumes are present in the output volumes folder in the geological model. Here we see the dacite. We can also drag in the basement. And finally, the andesitic tuff. We are now going to make a slice through the model. Here you can see the dacite intrusion in the middle of the two other lithologies. We can select the dacite in the shape list and set it as unsliced. We can do the same thing with the well data, set them as unsliced. We can see that the 3D geological model is fitting with the different lithologies in the wells, and you can also give it some transparency. In this last tips and tricks, we are going to discuss what are the common issues encountered by modelers with intrusion surfaces and what are the possible solutions. If some intervals aren't being incorporated into the right surface, try to check the surface resolution and check the upscaling parameters. If a surface is not honoring the input data, try reducing the resolution, and you can also try to adjust the snapping parameters. When a surface is too blobby, too round, you can try to add a trend, or you can also modify the value clipping parameters. If a surface extends too far and doesn't honor the well data, you can try reducing the background fill spacing in the point generation tab. If your surface doesn't extend far enough, you can try to modify the value clipping parameters. If too many disconnected, insignificant tiny volumes are being created, try to set the upscaling parameters to filter larger segments. This is the end of this video on how to edit intrusion surfaces built from well data. I hope that the tools and techniques shown will be useful for you and your modeling projects. If you have any question, do not hesitate to contact us at support.energy@sequent.com.